table. This works. All right, everyone, we're going to begin soon. We're going to begin now, actually, so let's just go. Welcome to my C++ practical C++ primer. Please excuse me if I seem a little off, if my voice is weak, or if I don't seem very prepared. I had a nasty case of strep the last 4 or 5 days. Just recovered from that, so that's a thing. It's a C++ course. We're going to be going over things starting now, so let's go. I'm Darian Glasser. Let's do a quick about me, just so you know who I am. I'm a computer science major here at UMass Lowell. I'm a sophomore right now. Technically, I could be a junior, but I'm in a co-op right now. I know Android, I know C++, I know C, I know Java. I know all your basics, so know that you're in pretty good hands for the most part. Organization. So let's go some more into this. Primary means of contacting me, we should go through Slack. Now, as I said in the email, I get a lot of emails every day. I get emails from work, and I get emails from other random things too. I get maybe like 40 emails a day. To make it so that your questions aren't lost and my communications are spread out throughout a single sort of modicum, Slack is the way to go. So if you don't have Slack, Slack is a general messaging app for Teams, and it's available on all platforms, Windows, OS X, Linux, as well as Android, iOS, and Windows Phone. Download the app, put in this link, cppprimer.slack.com, and you'll be good to go. You can message anyone you want there. In fact, this is also how I'm going to be doing attendance. So if you see right here, if you can, this is a slightly faded thing right here. This is sort of the way to say you're here in class. You're going to want to send me a private message with this right here, and that way I'll know you attended to class. You can do that now or later, I don't really care. Whatever works.
Just to confirm, that's a C, right?
That is a G. Okay. You could do C too, I don't care. You're not going to know what it is if you're not here. Anyway, number 2, direct contact. Say you hate Slack with a burning passion. This is a possibility. I don't necessarily agree with it. I don't think many people share your opinion, but you can do it anyway. And this is the email you're going to want to contact me at. So it's d@darianglasser.com. You are free to write this down. You are free to not write this down. You're free to put anything before the @. In fact, anything at darianglasser.com is going to be sent to me, but this is the easiest way to remember it. So that's probably what you're going to want to do. All right? Just going to give everyone a second to copy anything down that needs to. And finally, a class website. So we don't completely have a site. Now, this is partially because I was horribly sick the last few days and I couldn't get a site up in time. So we're using a proxy site. If you want to go to our site that has all our resources, darianglasser.com/cpp, and I'm actually going to go to it now. Where is it? And so darianglasser.com/cpp. And this actually isn't going to take you to my site, but instead it's going to take you to a place called Taiga. And Taiga is what I'm going to use to keep a wiki up of all the things we need. So if you want to go, it'll take you directly to the homepage. You can see resources, and resources are going to hold, I'll get into this in a second, template repository, and we'll also have a place for all lectures and any handouts that I put out. This isn't up yet, but if you want to go to a quick link right there, assignments and slides, you can check that out. And here we already have lectures and assignments. This already contains assignment 1. You're actually free to look at it right now if you don't want to pay attention to me. It's a bad idea though, because you should be paying attention to me. Okay, back to this. That'll be updated large amounts following days. As it is right now, it isn't super updated. It's incredibly bare. Very sorry about that. If I hadn't been feeling terrible, it would look beautiful right now. Great. Let's move along. Learning. What are you going to learn? What aren't you going to learn? This is important for you to know. You should come into this class with expectations, and you should come out of this class knowing what you aren't going to learn. You will learn. You're going to have a basic understanding of C++. All right? You're going to know what C++ is. You're going to know how it works. You're going to know why you want to use it. Nice. You're going to have a knowledge of object-oriented programming. Object-oriented programming is incredibly important. It's a massive paradigm in today's world, especially because many companies, use Java nowadays. And Java is a huge programming language used in Android, used in desktop applications. It's used everywhere. And you understand why OOP is useful. I kind of just explained that. But you know what? It's incredibly useful for things outside of Java. C++ is a great application of object-oriented programming. Next, what won't you learn? You're not going to learn algorithms. This is not a class to learn algorithms. This is a class to understand how C++ works. Sort of. You're not going to learn theory either. You will not learn how C++ works behind the scenes. Okay? You're going to learn how to write C++. Notice there's a little star there. We'll get to that in a second. And you're not going to learn anything that isn't in direct relation to C++. This includes compile commands. This includes optimization beforehand. This includes anything that is not strict C++ syntax or understanding. And we're going to talk about that in a second, a little bit further because of the template repository. Now, when I say theory, I put that little star there because you're not going to be learning theory unless it's required knowledge to understand how it works. Like we're going to talk about vectors, for example. Vectors are really cool arrays in C++, and understanding how they work could be useful. It's helpful in choosing the correct data structure for what you want to use. This is a reasonable reason to understand the theory behind C++. But just going into how virtual pointers work, that's not going to help you, so we're not going to do that. Alright, let's go right in. Class info. Now, this is some of the nitty-gritty stuff. We're going to be using GNU C++ 11 to 17 as our tool chain. What does this mean to you? Well, not a whole lot. Because I also did something. I made a CMake template repository. So if we go back to our class site, I'm just going to go back. Here we go. And I go to resources. You're going to notice right here, we have this thing called template repository. We'll click on it. And here we have a way to automatically build our projects. I'm going to talk about this a little bit more when we go to a second example. But for now, just know you don't need to know compile commands. Normally, if you want to compile a program, you would use, come on, get bigger, G++ --std standard equals C++ 11, and then you would do name of file.cpp-o executable. You don't need to do that. I made it so it's even easier for anyone who wants to do this, so don't worry about that right now. Cool. Let's go back to the slides. Alright. Recommended operating system. It's Linux. You don't need to use Linux though. But it's highly recommended to use Linux. GNU C++ 11 and to 17 are included, and if they aren't included in your distro, the one you choose, you can go about installing it using commands. This will be on the wiki on how to install the particular toolchain we're using if you don't have it, but chances are you already do. A great distro to use is called Ubuntu or Ubuntu. I don't know how you want to pronounce it, whichever way it works. And this is a great OS for beginners and a great OS for people like myself who don't like configuration, at least at the OS level. Now, is it possible to be done on OS X or Windows? Of course it is. You can definitely do this on OS X or Windows. If you're doing it on OS X, it's actually not too difficult. You just won't get support from me because I'm not running OS X, and because the device we're running everything on is called an Intel Edison, it's going to be running Linux, so we want the build environment to be similar. However, because OS X has that POSIX core, it's very possible to do all of this on OS X, and it's actually pretty easy to do so. Doing it on Windows is a little bit more difficult, but Windows does not include the toolchain we're using. However, you can still do it if you want to. It's just going to take some more work, and you're not going to get that help from me. So keep that in mind. I do recommend using Linux, though. And once again, the reason for this is that the device we're going to be building the satellite project on is an Intel Edison. It runs Linux, a version of Debbie and Debbie and Jessie, in case you're wondering. Anyway, moving on. Class schedule. Let's talk about how this is going to work. Because we only meet up once a week, we're not going to make it so everything is learning something new. We're probably going to take about half the class to review what happened last class, and then the other half of the class to go over new things. We aren't necessarily going to take a whole hour every time. We may do that. And we're definitely not going to go over an hour because I don't want to keep everyone here too long. Summertime, it's going to be 6:30 to 7:30, and that can be a long time for anyone who's here. Cool. So let's move right along. Anatomy of C++ program. All right? This is the stuff we want to know. How do we write C++? Before we get into this, though, is there anyone here who knows how to write C? Some people. Okay. Any brave souls like to come up here and write a main function in C? Nick, go for it. No, come up here. Type it out. Come on, friend. Write me a main function. Keyboard is a little weird. Could very well not be used to it.
Question. What is this?
That was quick.
Yeah, there.
Get out of here. No. Type it out. Bad Nick. So what is this? A main function is what we use to start our program. Everything that's in here is immediately run. Now, is this the correct form for ANSI C?
That's how we.
Wow.
I know our class did it slightly differently than the computing class.
Okay.
Because we did like the engineer version.
Mhm.
So.
So-
That was the first program.
Okay, sure. So let's just to explain what this is. If you don't know what this is called a main function. This function, well, really, a function is just like a little section of your code that can be called and run at any time. Cool. This main function is special. There's only one per program, and as soon as you run your program, everything in it is run immediately. Now, this strictly isn't how you would write a standard C main function, but it works fine in any revision of C, C99+. This main, and then int argc char argv return 0. This is technically how you would go about writing something in standard ANSI C. Now you don't need to do that anymore if you're working in newer version of C, but this is the idea. Now, does anybody know how to write a print statement in C? David? Go ahead, write me a print statement. And include any libraries that you need to make it work.
Question.
Yes.
Same question that I had 2 minutes ago. What is this program?
This is just a basic program with, it's just going to print something. That's it, it's going to display
No, I
this.
meant the window you're in. Sorry.
Oh, this is a program called Sublime Text. If you're looking for a text editor, I use Sublime Text. It's easy to use and it looks pretty. If you want to use others, there's also Atom. That's also nice and easy to use. If you want to use a different one, maybe you're a little more hardcore, Emacs, V, Vim. These are all ones that a lot of people use. That's beautiful. You take a seat. Awesome. These are all popular text editors. If you want an IDE, you can do that too. I don't recommend it for this class though, because it might be difficult to work with the structure we're using. So I recommend Sublime Text or Atom. Okay? That's the program. This, if you don't know what this is, we have our include statement here. And this includes standard in out. It's just going to print hello. I'm actually going to make it say print hello world because I like that better. And there you have it. That's a standard C program that just prints hello world to the screen. Now, I think that I'm actually just going to compile this. So let me make this window a little bit bigger. I'm going to use the C++ commands right here. G++, run, cpp. I want to find reference to main. Oh, I didn't save, I'm sorry. Save. IB. Run. Okay, and we're going to run this. Now wait a second, Darian, what is this? You just used a C++ compile command. This doesn't look like your standard C compiler commands. How'd you do that? Didn't you write this program in C? Well, of course I wrote this program in C. In fact, almost all of C is backwards compatible with C++. So if you write a program in C, and you want to compile it in C++, that actually works for the most part. Now, are you going to want to write C in your C++? Most of the time the answer is no, but you can, and that's the takeaway. So how would we rewrite this so that it looks more like C++ instead of just C? Well, instead of this, we're going to do a different include statement. So I'm going to do an include. And we use IOStream instead of stdio.h. Then instead of printf, we use std, standard, cout, hello world. Okay? This is different from printing. It has this command instead. We use what's called the insertion operator, and then we just write hello world. There's our function, and we're good to go. Beautiful. Now, Nick did right before. You can get rid of this. You can get rid of this. You can get rid of this. You can also do using std cout, and then you can get rid of this. And now you have a nice program, and we'll just run this real quick. Did I save? I saved. And now this also prints hello world. We didn't null terminate it, so we have that little weird thing right there, but that's the idea. So that's your first C++ program right there. Very simple. Let's make this so it looks a little bit more standard. Int. We have this right here. Return 0. And now we have our main program. Nice. Are there any questions so far on what I've done? No? Anything confusing? Awesome. Yes, go for it.
The window with the black screen, what is that?
This is called the terminal. Now, you're not going to need to worry about this so much, but you are going to need to worry about it a little bit. You're going to need to put a couple of commands in here to make your program build and run. We're not going to go into that yet, but I will go into that more with the following is in. Okay? Anything else? Yes, go for it, Silverio. Pronounce your name correctly?
Yeah. In some of like the upcoming classes, you can actually go through and talk about what each of the individual components do, or you're just gonna write a program and just show us what it does.
So this is
because that kind of just like looks like gibberish. So.
okay. I can explain what each of these does. I can certainly do that. That's fine. So let me go over what each part of this does. Here right now we have a main function. Okay? I already explained what a main function is. What a main function is just a function that runs as soon as a program begins. Now what is a function? A function is sort of like, it's a chapter in a book. No, do I want to write it here? Sure. We got like a chapter, we got a little chapter, we got one here, and then you can choose to make your reader go about reading parts of these. So when you call a function, you're just going to say, read this one, and have it do things, okay? The main function is special because it's always the first thing you read. But after the main function, you can have the reader go about reading anything they want here. You can have it read things multiple times, anything along those lines. Awesome. So, let's explain what this line is. We're going to ignore number 3 for now. Pretend it doesn't exist. This is the main function and what it looks like. Now, there are a couple of components to a main function. We have, or to any function for that matter, we have what it returns, we have what it's called, and then what it returns, what it's called, and then the arguments it takes. This right here. So what it returns is that when we go about calling one of these functions, we're going to get something back, or we're going to get nothing back. Because this has int here first. When we call this function, it's going to return a number. Now, technically, the main function doesn't need to return a number because it's only a main function. But in standard C world, because we want to keep compatibility, it does. You don't need to understand why right now, it's just, it does. Alright, this is the name. It's called main. And then we have these little parentheses right here. This is where arguments go. So if you want to pass data into your function, this is where it goes. Finally, we have this curly bracket right here. The open curly bracket shows where your function starts, and the closed curly bracket shows where it ends. Okay? Does that make sense so far?
Yep.
All right. Then, inside these two curly brackets, you can put whatever the heck you want. So, Cout or see out is used to print things to your screen so people can go about seeing what happens. So what we do here is we call this see out. We have these two operators. They're two lesson operators? I think that's what they're called. They're also called insertion operators. And that just designates what goes into this function right here. Okay? And we put this string. It's called hello world. Anything we put between two quotation marks is called a string. So we're just taking this, putting it into that right there. When we do that, we can run the program, and we get this printed to the screen, so we can see it. Okay?
Well, the return 0 line, what would happen if you altered that to say like return 1?
So because this is a main function, it doesn't matter what we return here. We can have it return 1,000.
Oh,
We could actually get rid of the return function here, which in standard, oh, we can't? Oh, no, that was that was a different error. One sec. So we can actually just get rid of it altogether, and it still runs. Now, because it has this little thing right here, where it says it returns an integer, technically you shouldn't be allowed to do that, but it's a main function, so it's special. So you can have it return whatever the heck you want. Does this make sense so far?
yep.
Okay. Finally, this line right here, line number 3, this is a convenience line. This makes your life easier. So normally whenever you call cout, you should have to do this, std, ::, which means it's part of the standard library. When you put that up there, it already knows that you're using standard cout, and you don't need to worry about it. Awesome. Any other questions about this? Take your time. Yes, go for it.
So you said you didn't null terminate the string.
So when you're working with cout, technically you're also supposed to end it with endl. So we'll make it so it's valid. Oh, I'm using IntelliJ shortcuts here. So when you print something to the screen, if you don't have this thing right here, endl or end line, then you're going to get this little artifact at the end because it's not null terminated. Now, if we run the program, it no longer has that ugly little thing right there at the end because we terminated it using endl. Okay? That's all there is to it. You should always do that, but for this example, I didn't know if it was necessary or not. But hey, there you go. You know now. Anything else? Go for it.
It's kind of just probably a small thing, but the first line, what does that mean? Include IO stream?
Oh,
Is that just a
it's called a library.
type of thing?
Okay, so everything you're using here isn't automatically included. It's like, let's say you're going to build a bridge. No, let's not do a bridge. Build a table, okay? Get one from IKEA, because IKEA's got great tables. Now, in your head, you don't really know how to build a table. You've never built a table before. Maybe you have. I don't know how to build a table. So you go into the box, you pull out the instruction manual, now you're a master of building tables because you have the instruction manual. This is the idea with these programs. Out of the box, they don't carry around all these instruction manuals to do everything, because if they did that, they wouldn't know how to do it. They would be really slow when they tried to read how they did things. So, when we try to do something, in this case, print using cout, we need to include this thing right here, IOStream. This is a manual that shows the program how to print. Alright, as you use more C++, you'll find out more libraries you need to include using this syntax. Octothorpe include, and then the thing you want. But for now, just know IOStream is used for printing. The IO is for in, out, and stream is for C streams. Okay? Does that make sense? Cool. Any other questions? Let's move along. So the anatomy of a C++ program, pretty much what we just went over. We have an include right here for user-defined libraries, so we can make our own libraries. This should actually be in quotation marks, not in what are these called? Greater than, less than signs? But whatever, anyway. And then we also include built-in libraries as well. So the built-in libraries are like IOStream. That's a library that's built in, and we'll show you a user-defined library later on. Next, we go about defining our methods. We'll talk more about methods and functions in just a moment. We have our main method. This isn't in every file. It's only in certain files. And this is only once throughout the entire program. You can only have one main method. And then from there you have your method definitions. So you declare your methods, you define your methods, up at the very front of your program or in your header files, and we'll go into that in a second. And then you have your method definitions, what they do that comes afterwards.
Are methods and functions the same thing?
No, they aren't. Talk about that in a second. Okay, any questions? Have at it.
Just that I've never seen the word method, the terminology method before.
Don't you worry, we'll go into that. Cool. Differences to C. For those who know C, let's talk about this real quick. What are the differences? Well, strings exist. If you had to work with strings in C before, they weren't really strings. They were arrays, or they were null-terminated arrays, or they were pointers with letters after them. Now you got real strings. It's amazing. You're going to find out that working with these is so many times better than they were in C. Although if you try to work with strings in Java, oh my god, so much better. But you didn't hear that from me. There's auto memory management. Amazing. If you had to malloc and calloc before, you don't need to do that anymore. You do a little bit. You still need to manage memory. But in a lot of cases, if you're working with dynamic memory, it's going to do it on its own. Amazing. Or you can make it do it on its own. That works too. STL, the standard template library. This is a bunch of convenient stuff. These are a bunch of convenience methods and objects that you can use in your own stuff to make your lives a whole lot easier. You know how you had to make dynamically sized arrays before in C? You don't need to do that in C++. Why would you ever do that? Someone else has already done it, and they've done it in a better way than you're going to think about in 5 minutes. Use a standard template library. We'll go into that later. Not this class, though. Variable declarations. If you used ANSI C, your variable declarations don't need to be up top, and they can be defined in loops. Sounds like a lot of you didn't need to worry about ANSI C too much, but this is a case where you don't need to worry about it anymore. Raw pointers versus unique and shared. Previously, if you're going to work with a pointer in C, you would do this little asterisk thing, and now it's a pointer. The problem with pointers is that managing them on your own is a real pain. They can create memory leaks all over the place, and you can get seg faults all the time. In C++, there are these things called unique and shared pointers. Old pointers that you used are called raw pointers. The ones you're going to use are unique and shared. These are going to make your lives a lot easier, and they're going to manage memory on their own a little bit, which is really nice. Variables can't be called class. If you ever named a variable class in C, you're going to be disappointed. You can't do that anymore because there's a real class in C++. Awesome. Object-oriented design. You didn't have that in C. Now you could define your own object-oriented in C. This is actually a thing, and people used to do this. And then they said, let's make this easier, and they made C++. So this is the big sticking point of the difference between C and C++. You have object-oriented. Now you're probably like, Darian, what the heck is object-oriented? What's the difference between a method and a function? Stop yelling at me, you're sick. But I'm not actually sick anymore. So let's go into this. What is object-oriented design? What is a class? What is an object? And what is the difference between a method and a function? That should be up there, but it's not. So I didn't even think about that, to be perfectly honest. So first, let's go over some rudimentary stuff. An easy way to understand object-oriented design. Here's a truck. Who doesn't love trucks? Maybe, what do we call that truck? Is there a better name for that?
Dump truck.
Dump truck, sure. Okay, it's a dump truck. What attributes does this dump truck have? Quick, go ahead. Anyone? It has wheels? Oh my gosh, it has wheels. You're right. Let's write it down. You got wheels. Actually, I can do this on my computer. Make it easier to see. It's impossible to see. It's got wheels. Nice. What else does this have?
Diesel engine.
It has a diesel engine. All right.
It's a big bucket on the back.
A big bucket on, you know what? We're going to call it a carrying thing. Nice. Okay. Anything else? Anything else important?
Cab.
Headlights.
It's red.
It's red? You know what? We can say it's red, sure. Was there something else I heard?
That's headlights.
Headlights. Lights. We can call them headlights. Cool. And we can say that this is... Okay. This is probably good. We got enough examples for what this thing is. So what's this? This is a car. I don't know what type of car it is. It's a clip art car. It's royalty free, that's what it is. So, we can also say this has certain attributes that are very similar to the truck, no? This has wheels. This is red. It doesn't look like it has lights, but I'm going to say it has lights. But this isn't a truck. This is different, but it's similar. We can say these are both vehicles. Okay, but they aren't the same. So, this is probably better drawn out. The idea behind object-oriented is that you have an idea. It's called vehicle. Alright? These are both vehicles. We both know they have wheels. We both know they have the color red. We both know they have headlights and they have windows. But, even though they both have all these attributes, they aren't made the same way. So, what we do is we make this thing a vehicle, and it's going to have some basic attributes that both of these have. Then, each of these sides, truck and car, this is the worst marker in the entire world. Vehicle. I'll just use this first. Truck, car. This way we have some of the basic stuff that both of these use. They both have engines, they both use gas, albeit different types, they both have windows and wheels. But then we can make it so that each one of these has separate attributes that are slightly different than the others. And an even more radical example, this plane right here is also a vehicle. It has standard attributes that all of these have. But it's very different from these two. A plane can fly. Either of these can fly. So it's also different too. Fine. So when we're working with object-oriented, the idea behind object-oriented is that we create a standard sort of prototype, and other things are able to build off of that prototype and make their own thing. Cool. This is the basic behind object-oriented design, and this is a big reason we're using C++, because we can do this. It makes it a lot easier. So, let's talk about the technical terms behind these. What is a class? A class is the prototype that we talked about. A class is vehicle. A class is truck. A class is car. A class is plane. It's like flag. A class is more or less the instruction set that tells you how each of these things are going to be defined. Okay? An object is an instance of this class. So, maybe I own a truck, but maybe Nick owns a truck too. Why can't Dad own a truck? Why can't Becky own a car? Why can't I own a plane? Why can't I own 3 planes? Sure, we have the instructions here, but an instance of this is called an object. So when we make a truck, that's called an object. The instruction set itself is called a class. Cool. Does that make sense so far? Go for it.
So, one thing.
Yes.
Class is the vehicle, like vehicle, or it's truck?
So, if I give you a manual, this is a little bit different than we talked about before. If I give you a manual on how to build a truck, that's a class. If you build a truck using that manual, that thing you built is an object. Does that make sense? Anything else? Yes.
Could the truck, car, plane be called a subclass? Or
Yes.
Okay.
Could be called a subclass. We're not going that far yet. We're not talking about inheritance. I just want the basic ideas down first. Yeah,
Is there
David.
a difference between a structure and a class?
Yes, there's a huge difference. Everything in a struct or a structure is public. Everything in a class, by default, everything in a class by default is private. And we're going to talk about why this is important later on when I'll actually show you an example of a class. Okay? And finally, a method versus a function. So I talked about functions before. Here's a function. It's called our main function. I'm going to make another function real quick. So to make a function, we need our, what is our function going to return? If it returns nothing, we do void. I'm going to give it a name. I'm just going to say hello. It's going to take no arguments. There's a colon. Good. We've made a name for our function. Now I'm just going to make our function. I need to say it again. Hello. Okay? So this is where we said that we have this function. And this is where we actually made the function. And we can write stuff in and make it do things. Hello. This is a very excited one. This one had too much caffeine. Then, we can call our function like this. Okay? This is a function. And we'll just run this real quick to show that it works. And now we have our hello world and our very caffeinated hello. Nice. Okay? So a function is just one of these chapters that I talked about before, but it's not in an object. It's not in a class, I'm sorry. Now, when we have a method is different from a function in that methods are found in classes. Okay? That's the only difference. You still define them the same way, or it's a very similar way, but they're in classes, and that's what makes them a method versus a function. Does this make sense? Are there any other questions about this? Are there any? Actually, are there any? Yes.
So is that like the only difference between a method or a function? Like, could I easily put that hello in a separate class?
Yes.
It's technically a method, even if it's the same thing.
Yeah, you could put it in. The only difference is that it's in a class or it's not in a class. Now we can go into pure functions and static functions, and then you can debate whether or not they're methods anymore. But that's the idea. If it's in a class, it's a method. If it's outside of a class, it's a function. Okay.
So aside from that, there's no like functionality differences.
Anything else? Becky,
What does it mean to be in a class?
we're gonna make a class, and you're gonna see. Okay. So, anything else before we move on? No. Let's move along. How to make a class. This is the entire reason why we're using C++. Because we can make classes, and because we can have this object-oriented design. If we didn't have this, well, we might still use C++. It's a lot nicer than C. But you know what? This makes it even better to use C++. Because we get this magical object-oriented design and we can work with it. Awesome. What's the syntax to make a class? Well, first we write this identifier, class. Then we have a name. We call it simple class. We call it whatever the heck you want, as long as it isn't class or any other identifier that we use. Alright, then we have this identifier called private. What goes in private? All of your data members and your private methods. And you're probably like, Darian, what the heck is this? Actually, I got a real question. I don't even need to make one up. Dave, what is it?
If things are private by default, do you need private?
No. It's good practice. Good question. So, we have this private right here. This is where you put your data members and private methods. And then we also have public. And this is where you put your constructors and public methods. Now let's take a quick explanation of what this stuff is. And why do we care about private, and why do we care about public? So, let me get my marker. Let me just throw this marker right over here. So, say Silverio is building a truck. Actually, no, he can build a plane. Way cooler. He built a jet plane. Yeah. All right. He's got the instruction manual. And he's been poring over this for years. He's got a PhD in jet plane making. He's the premier jet plane maker at UMass Lowell. And he's going in. He's making this amazing plane. You know, it's got like red flames on the sides. He's ready to go. He's ready to sell it to President Barack Obama or something. I don't know. And he needs to finish working on it. And he wants to make it look amazing. So he continues painting it. And then Nick's like, you know what? I don't want there to be red flames on it. I would really like there to be dogs on it. So he just starts painting little chihuahuas all over the thing. This definitely isn't good for the president, but you know what? He can do it anyway. Why? Because in this case, we made it so the plane is public. While we're making a thing, we want to make it so that certain things in this object or class, either way, cannot be accessed by anyone outside of the class. This is important because people can go in and just mess things up and put chihuahuas on your plane. Who wants that? I don't want that. So, when we make something private, we make it so people can't access it and mess it up. You have to assume when you're writing a program, anyone else who looks at it, including yourself, has no idea what they're doing. And if you give yourself a couple weeks, that's going to be the case. I'm 100% serious, by the way. Now, public things. These are different from private. These are things that you're allowing other people to use. Silverio finishes his beautiful plane. It's ready to go. He's painted over Nick's chihuahuas. He's made it private now so no one can access it. And now he wants people to use it. So he's got a method. It's called fly. People can get in this plane, they can fly. He's letting anyone do it because he doesn't feel safe letting just the president do it. Awesome. This is a public method. Okay? Does this make sense? Yes.
So you would never have private and public together, would you? Or would you have both together in the same curly brackets? Private and public?
You would. Because in this case, we have our class. And we have this curly bracket right here. We have this curly bracket right here. There's only a single pair. Once we put private here, anything inside here is private. Until we have a separate tag, public. Because we have this public here, everything under this public is public.
And if you wanted everything to be private, you would just have no public.
Right.
Okay.
But you wouldn't want that. It's a bad idea. You also wouldn't want it all to be private either. You also wouldn't want it all to be public either. I'm sorry. So, you're going to need a way to for people to make this class, because you don't want to make it exclusively for you to be made. So you're going to want to make the constructor public, and we're going to talk about that in a sec, so don't worry. Becky.
Could you also declare private again under public, and that whatever's under that would be private?
I'm going to say that's bad practice, and you shouldn't do that. I'm just going to put a little red flag. In theory, that is how it works. Have I ever done it? No. Do I recommend doing it? No. Am I gonna? You're gonna pass in your homework like that? No, because I'm gonna flag it. You're gonna say, redo it. That's how the syntax works. That's correct.
Okay.
So, let's go into making a simple class right about now. Because you know what? This is what your homework assignment's going to be about. It's going to be making a class. Well, it's going to be some other basic stuff first. It's going to be making a class and doing things with it. So let's go. And actually, I'm going to go into how you do this if you were just starting fresh. So I'm going to daringglasses.com/CPP so I can get my resources. And we're going to wait for EduRoam, or EduRoam, however you say it, to do its thing. It's going to load. I swear. Well, it'll eventually load. Let's pretend it did load. And from there, we can go to github.com. Wait, it's actually loading. It's not actually loading. What's going to happen is that you would go to, I'm just going to open up a little text editor thing so you can see. It would open to Taiga, which is where the wiki is. From there, you click on template, or you click on resources, And then you click on template repository. Okay. Just see if it's loaded. It's not loaded yet. I'm actually gonna turn this off and turn it on because I'd really like to show a demo. Let's give it one more second. I wish there was a hard line here. That'd be awesome. I don't see any Ethernet though. Wait. No, there's definitely no Ethernet here. Okay, let's refresh the page, see if it does a thing. Oh, it's not. Okay, so we'll pretend it worked. You're going to see this template repository. What you're going to do is click on releases, and it should show it like right over here. It's not going to show it immediately where it is. And you're going to download the thing. Download. My hands are getting chilly. And oh, there it is. Finally. Resources. Boom. You're going to click on this. It's going to take you here. You're going to click on release. Here it is. You're going to click on template.tar.gz. This is really just a zip file that's most often used in Linux. Then you can go about unzipping it. I'm going to unzip it in the terminal, but if you want to unzip it on your own machine just by right-clicking and clicking on zip, you can do that. Downloads ls tar-c tar-c zxvf and template.tar.gz cd template repository. Cool. So I just unzipped this file and I went into it. And to show how it works, if you're using Ubuntu, and you don't want to use that, go to Downloads, right-click, Extract here. Now let's make a simple class, because we can do that. Now what's special about this this build system I made? This is the template repository, and this is supposed to make it so you don't have to do half as much work as you should. Every time you go about adding a new file, normally in C++ or C, or really pretty much any language, you need to do the command, your compile command. So we call the compiler using G++. Then we need the name of every single file we're going to use. So we call 1.cpp, 2.cpp, and then 3.cpp. And it'll go on and on and on. And then we'd need our -o, and then we need to call whatever we want to name thing. That's what it's called. If files are anywhere else, it's going to be a real pain finding them. If we have any dependencies we're working with, it's going to be a real pain adding those in. Every time we add new files, we need to add those into that command. Anytime we need to rerun it, we need to type that command again. It gets to be a pain. So I made that easier for us. And what we have here, let me do this again, is we have these three folders. We have build, we have include, and we have source. And we also have these things right here, license, readme, cmake, text list, so whatever. All of your C++ files go in this folder right here called source. All of your header files, we'll talk about that in a second, go in your include folder. And then we need to run your program. I'll show you how to do that in a second. We're using a build system called cmake. If you don't have cmake on your system, what do? If you're running Ubuntu, you would run the command sudo apt install cmake. Okay? This is going to install cmake. It's already installed in my system, so we're good to go. Done. Let's make a class. So I'm going to go into our source folder. And I'm just going to subble. Actually, no. Let me think. We're going to go into our include folder first. I want to make a header file. And before we do that, I'm going to explain what a header file is. So, subble. What do we want to call this? Anybody have any cool names? No. Cool name. .h. Too late, guys. Check out how cool this is. Alright, what is a header file? Now, while you're writing out all the stuff
it can be a real pain to say every time you want to make something new, you have a little definition on top. So, say for example, what's a good example? I can't think of a good analogy right now. If we go back to our last file, you can see we have this definition right here. Every time you make a new function, you have to include that at the top. That makes for a lot of visual noise at your program, and it can be a real pain to read. A header file is just a place to have all of these definitions, so there's less visual noise. Does that make sense? Okay. So let's go about making our header file. This is where we actually say class, and we start working with our definition. So I'm going to type class. Open curly bracket means it starts, and we need a name for this. We're going to call it the same thing as the file name, and it's exactly what you should do too. Cool name. Awesome. We've made a class. Now, we need something else. When we start working with the class, we need to make what's called a constructor. We need a way to make it so every time this class is created into an object, it follows a certain instruction set to begin. Now, you need to write this instruction set. It's not just going to happen magically. This is called a constructor. So when you construct an object, it makes it awesome. So let's make a constructor. The way you write a constructor is the same way you write a function or you write a method, except it doesn't have a return type. So we write cool name. This one is going to take no arguments. Open and close curly bracket. Actually, no, sorry. This is a header file. Cool name. There it is. That's a constructor. And remember, we're in a header file right now. We're not writing how it works. We're just writing that it's there. But wait, Darian, aren't you missing something? Yes, you are definitely right. I need to write public. Now people can access this. Awesome. I'm also going to have a single function here. We're going to call it run. Cool. In addition, we want to store some data in this class too. We don't want people modifying this data though, so it's going to be private. And this is always how you want your data members. Make them private unless there's a very good reason not to do so. And there's always a reason somewhere. But in this case, by default, you should make your variables in here private. Okay? So I'm just going to make an integer, which is just a number, int. And we're going to call this something. Cool thing. What? Something. Oh, even better. Look at this. Something. Okay? It's an integer. We gave it a name. We gave it a colon. Cool. We're almost done. Yeah, what's up, David?
Does run need a return type, or is it a constructor?
It does need a return type. Good save. See? I told you I'm not in my game. What do you want to return? Wrong answer. Nothing.
Why does it need a return type?
Because it's a function. It's a method. I'm sorry. This is a method. The only methods that don't need return types are constructors. That's it.
Oh.
Okay? So right now we have an integer. This is called a data member. We have our constructor. This is what we're going to use to make our object, cool name. And we have our singular method right here that we can call and run. Awesome. I also want to make it so the user can put in a number when they make this class. So what I'm going to do is I'm going to make an argument, int, and we're going to do input. Now when the user goes about making this, they have to include an integer. Great. So this is our header file. We're done with our header file. It's done. Let's make a C++ file to go with it. What's up, Nick?
Do you need the cool name with empty brackets as well? Or?
This is a header file. We don't have empty... Wait, what do you mean?
I think I remember, maybe I was, but I had cool name with like something that had empty brackets, and then I actually had like, cool name with arguments in it. A default constructor?
That's called default constructor. We can go into that later if you want. I'm not a huge fan of making default constructors.
Okay.
Now,
you can make a default constructor, and it can take nothing there. What this does is it makes a constructor, it makes an object, and it has nothing in it. Or it takes nothing, and it puts defaults in. I didn't do this at start. You can do it, though, if you want to. We're not going to do it right now. Okay? We're slowly running out of time, so we're going to zip through this, and we're going to make a new file. Oh, this is not where it goes. Where's our terminal? This is our terminal. This is not our terminal. I'm just going to open a new terminal. CD downloads. Let me just make this big again. So we've made our header file. Now we need to make a C++ file that goes with it. Subble. This is the command for my text editor. You can use whatever text editor you want. You can just make the file by right-click, make a new file, whatever. We're just going to do coolname.cpp. This is going to be the accompanying C++ file that goes with the header file. Now, how does it know it has any relation to this? It has no idea that they're friends. It has no idea they're related at all. So we've technically made a library here. We need to include this library so that anyone else can use it. So what we do, include, and in these quotation marks we do cool name .h. Bam. Now it knows they're related. Now we need to make these functions, we need to make sure these methods actually have something in them. I'm going to go split screen right now because I'm that cool. Bam. Header file on the left, C++ file on the right. Left, right, yeah, whatever. Now, let's make our constructor. So, when we're referencing a file from a header file, we always need to reference it using the same thing we did before with std::cout. But instead, we're not working with the standard library. We're working with this header file. So we need to do cool name main : and then we can have a name of our constructor or our function here. We're going to make our constructor first. Cool name. It's going to take int input. It needs to do something now. Let's make it do something. What is it going to do? Something equals input. What did we just do? We took this argument that the user puts in, and we set it to this private data member we had. As long as this object is alive, that's going to always be set to what the user set it to, unless we decide to change it. Alright. Next, we need to define this function we made, run. So we always have the return type first, void. In this case, it's void. It can also be any other type you want it to be. We need our cool name prefix. Cool name. Run. Then we need our opening and closing curly brackets, and then we can have it do whatever we want it to. Now I'm just going to have run print things. So because we're going to print, what library do we need? People who don't know C, don't answer. People who know C, don't answer. What library do we need if you don't know? STD.
::cout.
No. Not yet. No, sort of. We need to include, and this is called IOStream. Now we can print. I'm also going to include that though, you're right, using std::cout to make my life a little bit easier. But this include IOStream is really what we need right now. Okay? And then, what am I going to do? I'm just going to print, so cout number, something. If we want to add more things to our string, we need 2 more of these insertion operators right here. We can put whatever the heck we want here right now. going to put something here. And then I'm just going to put using std endl. I'm just going to put end line here so that it's properly terminated. Cool. What's up?
This looks a little different than C where you have to put %D.
Yes. So if you've ever used Java, this is very similar to that. String concatenation in C++ is easier. Every time you want to add something new, you do these little insertion operators right here. And then this goes after it. Then we do this goes after it. We add something new here. Personally, I kind of like the C way better, but yeah, I don't have that option. What's up?
So could you have done using cool name and cool name run? Or am I misunderstanding? Or you can't use that when you're...
Now, that's a good question. You can use using namespace cool name. Can you do that? Yes, you can. There's an even more popular way more popular thing a lot of people do using namespace std. This means you never have to reference std : for anything. But if you do this is sort of like carrying every manual around with you. It carries a lot of overhead. I recommend not doing it, but you can do it if you want to. Okay? Global namespaces are really powerful. You want to make sure you don't abuse them. Okay? Any questions so far? We're almost done.
So what does using namespace cool name do?
Then we could slice out this, and we could slice out this. Makes it look a little bit more ambiguous now, though. That also means that you can't have any functions that don't reference cool name. All we need to do now is just make a main method and call this, and we're done. I'm going to make one more file, subl main.cpp. I'm going to make a main method. I need to include, and this is cool name.h. Now I just need to make a cool name object. So cool name. And to make an object, it's sort of just like the way we do it with a function. 2 parentheses. I'm going to put an integer in here. I'll love the number 5. We're going to put a 5 in. Oh, and we need a name. I'm sorry. Oh my god, I hate making names. Thing. Cool name thing. So here, we have the type. It's a cool name. Here, we have the name of what it's called. And here, we have our parentheses, and we input the argument, which is the number 5. If we want to run this, now we do thing, which is the name, dot run. And this is just going to print our number 5, or it says something : 5, I don't completely remember. And that's it. So let's just run this, make sure it works. And this is how you run a program using CMake. So I'm going to go into our build directory, and these are the commands you're going to need to know. Type CMake ... This builds the make file. Then anytime you want to run the program, you type the command make. Oh, my battery's low. Oh. I forgot a colon, I'm sorry. We need a colon after our class definition. Colon. Make. And now we can do cd into our bin folder. This is where your executable is located. To run a program, you use the command // and this is called hello world. Run. And it prints something : 5. And if you look at our source code, this is exactly what we wanted. Something : and what the user input, which is 5. Alright, that's all we have for class today. You're free to go. You have an assignment. I don't know if I went over everything we need to do to get the assignment done,
But try to do as much as you can. If you have questions, ask me questions. I'm open to answering questions any single time. To get to your assignment, you go to daringglasses.com/CPP. You can go to assignments, and there's one other thing, and then you just go there, you download it, you're good to go. All right? If there are any more questions, ask away. You're free to leave. Have a great day, everyone.